G'day lads, in this video I'll show you how to build a basketball model to analyze probabilities for the money line, spread and total points for each matchup using team stats. If you wanted to save time or join the Excel Lads sports modeling community, then you can download this model for daily analysis as well as the player-based NBA model shown here by clicking the first link in the description below to go to the Excel Lads Patreon. Enjoy the video lads. Starting off with a blank spreadsheet, lads, you're going to name this raw data. And in this worksheet, you're going to use a Power Query to connect the model to the website Basketball Reference so that the model is able to update its stats automatically every day instead of you having to copy and paste data, which may take a long time. So Basketball Reference, I've got the link in the description below. This website's got the conference and division standings as well as per game for and against stats for each team. So I'll do the Power Query right now because this process is different depending on which version of Excel you're using as well as your computer. So if you don't know how to do that, search up a tutorial on YouTube. It's got the per game stats for each team as well as their per game opposition stats, so how many points that team concedes each game. So once that Power Query has been established, you're going to make a new worksheet and name this NBA team stats. And in this worksheet, I'm going to collate all the stats in the raw data worksheet. Because the Power Query process is so tricky, this may be presented in different ways depending on your version of Excel. So the main thing here is collecting all the stats, and if you have to use a different formula to what I'm using in the next couple of minutes, you may have to do that. So from cell A1 across to G1, put the text team, 2 points for, 3 points for, free throws for, and then 2 points, 3 points, and free throws against. So for the teams, just grab a list of the teams from the raw data worksheet. Here it'll be raw data B81 to B110, and I'm just going to copy and paste the values over the top so that it's purely just text rather than an array. Now I need to pull in the 2-pointers made per game for every team in the range A2 to A31, as well as the 3-pointers, free throws, and then how many they concede each game as well. So for the Cavaliers, I can use the formula equals VLOOKUP. The lookup value will be Cleveland in A2. Put a $ in front of the column A so that I can drag it down and across. The table array will be B81 to Y110. And then the column index number is going to be 10. I want to return the 10th column in this array, which will be the 2-point column in column K here. So false for an exact match, and the Cavaliers score on average 30.6 2-pointers per game so far this season. Drag that across to D2. Now for the 3-pointers for, that's in column 7 of the array B81 to Y110 of the raw data worksheet, and the free throws for is in column 13. So drag B2 and D2 all the way down to row 31 to fill that out for all the teams. Now I've got to do the same thing for the 2-pointers, 3-pointers, and free throws conceded each game by each team in column A. So that's the same exact formula, VLOOKUP, same lookup value, the team. You're finding the team in the table array. This time, scroll down for the per game opposition stats in B115 to Y144. And on the Basketball Reference website, this is just the table below the team per game stats. Column 10 again, comma, false for an exact match, and the Cavaliers concede less 2-pointers than they score, which is a good thing. So drag that across, and again, same thing, the 3-pointers will be in the 7th column of that array, and the free throws against will be in the 13th column. So drag E2 and G2 down to row 31 to fill that out for every team. And now I've got each team's stats that'll be useful for the model. I need to make an average though, so in cell A33 put the text average, and then beside it in B33 use the function average, and then it's just simply the average of cells B2 to B31. So close the bracket and then drag that across to column G, reduce that to 1 decimal place, and then each value should be the same for free throws for and against, and for the other methods of scoring. If there's a slight difference, that's just due to a rounding error. Now make a new worksheet, lads, and in here, name it NBA Team Ratings. So in here, I'm going to rate a team based on how well it scores 3 points, 2 points, and free throws, as well as how well it concedes them relative to the league average team. So from A1 across, put the headers team, 2-point attack rating, 2-point defense rating, 3-point attack, 3-point defense, free throw attack, and free throw defense. Now in A2, I'm going to copy and paste the teams from the NBA team stats. And again, I'll just need the list of teams in exactly the same spot. And in a fashion similar to what we did in the NBA team stats worksheet, I've got to format this so it looks good and then find the attack and defense ratings for all the methods of scoring for each team in the range A2 to A31. Starting off with Cleveland in cell B2, I'm going to use the formula equals VLOOKUP. My lookup value is going to be the team in column A. So in this cell, it's $A2. Put the $ in front of the column so I can drag the formula down and across. For the table array, it's going to be A2 to G31 in the NBA team stats worksheet. Absolute reference that, comma. I want to choose the second column. That's the 2 points for in column B, and then put false for an exact match. So close the bracket and then divide by the average in cell B33. So this formula returns Cleveland's average 2 points for per game and then divides that by the average team in the league and how often they score 2-pointers. And we can see here Cleveland score about 10% more 2-pointers on average every single game. So I can do the exact same thing for the defensive rating. So here it's a VLOOKUP formula. I'm looking up A2 Cleveland within the A2 to G31 range. The column I want to return is the 5th in column E this time. That's the number of 2-pointers Cleveland concede per game. I want an exact match. Close the bracket and then divide by the average in cell E33. Absolute reference that too. And then drag that down to column 31. So Cleveland have a relatively good attack rating. They score 2-pointers 10% more than the average team, and a good defensive rating too. A defensive rating of 0.96 means they concede 2-pointers at a rate 4% less than the league average team. So drag the formula from C2 across to G2, and then all I've got to do is change the columns here. So for the 3-point attack rating, 3, and then divide by C33. For the 3-point defense rating, I'm looking up the 3-pointers conceded in column 6 of that array, and then dividing by the average in cell F33. And then I'll do the same thing in column F. I'm looking up column 4 and then dividing by D33. And then for G, it's also the same exact change. I'm looking up column 7 and dividing by cell G33. So press enter on that, and then you can drag those formulas down to row 31. And then the average rating for each column, so B, C, D, E, F, and G, should be about 1. I'm also going to do a home advantage of 2.5% in cell B33, and that's proven to be historically accurate. Next, lads, I'll create a new worksheet called Dashboard, and in here we'll be able to select 2 teams, see their expected points in the matchup, as well as the probabilities for the 3 main betting markets, the money line, spread, and under over total points. So after I've created the new worksheet, merge and center the cells B2 to D3, put the text away team in there, do the same for E2 to K3. In here we'll be able to select the team. From L2 to M3, that'll be where the expected points are, and then from N2 to O3, the win percentage for the away team, and copy and paste that into row 5 for the home team. Now, before I'm able to get the expected points and the win percentage for each team, I've got to be able to select the 2 teams in E2 and E5. So after you've applied color scales in cells N2 to N5 to highlight the team with the most likely chance of winning in green, select cells E2 to E5, go into the data tab, and then in data validation, allow a list. Our list will be the list of teams to choose from. So that can be anywhere, but I'll go equals NBA team ratings A2 to A31 as my range. So press OK. And then once you do that, in the top right hand corner of the cell after you've selected it, I can click the drop down list and then select a team here by scrolling down. My first team will be the Atlanta Hawks, and then I can choose their opposition. So this game is the Hawks at the Bulls, and obviously the expected points in columns L and M and the win percentages for both teams in columns N and O will update based on the teams you select, how good they are, and their strengths and weaknesses. So after you've done that, merge and center the cells A8 to O8 and put the text money line, copy and paste that into rows 13 and 19 and put the headers spread and under over. Now for the teams, put equals E2 and equals E5 in A10 and A11 and win percentage and odds next to it. Do the same thing in A16 and A17 and then put the text threshold under over for the under over market there. So now that I've created the formatting for the dashboard worksheet, I can go ahead and make a new worksheet called simulations. In here, we'll simulate one game between the Hawks and the Bulls and then repeat that process 2,500 times to learn about the distribution of results for that game. And from there, we can determine how often the Hawks win out of 2,500 trials, how often the Bulls win, and how often the points go under over the total, as well as how the spread behaves. So make the teams in F1 and G1 equal to dashboard E2 and E5. Then in cell E2, put the text regular time. First, we've got to simulate the regular time score between the Hawks and the Bulls. And then if need be, it can go to overtime 1, 2, and I'll cap it at 3 overtime periods in this model. But going past that is pretty unlikely anyway, and probably won't happen in any of the 2,500 trials. So to start, I'll need to get the expected points for each team to show in the dashboard, and to calculate that, I need to start by finding the expected free throws, 3 points and 2 points each team scores in a game. So in A2 to A3, put the text away and home advantage. Below that in A5 to A6, away and home expected 2 points, then away and home expected 3 points, then away and home expected free throws. Now using all of the multiples above, it's possible to find the away and home expected points, and those figures we'll put back into the dashboard worksheet when we work them out. Now, after you put all that text in, we can calculate the away and home advantage. We put earlier that the total advantage for the home team is 2.5%. So we'll use a multiplier so that it goes both ways. It reduces the away team's expected 2 points, 3 points, and free throws, and increases the home team's scores by the same effect. So for the away advantage, it's 1 divided by the square root of 1 plus 2.5% in cell B33 of the NBA team ratings. And for the home advantage, it's the reciprocal, just the square root of 1 plus 2.5%. So once I reduce that to 3 decimal places, I can move on to the away team's expected 2 points for the game. And I can solve that with an XLOOKUP function or a VLOOKUP function if you're using an older version of Excel. So that's equal to VLOOKUP, open bracket. My lookup value will be the away side because I'm finding the away expected 2 points. And I'm looking up F1 in the table array A2 to G31. So I'm matching the Atlanta Hawks, wherever they are in A2 to A31, to their attacking 2-point rating in column B, or the second column in that range, and then multiplying that by another VLOOKUP function where I search up the Bulls, the home side, in the same table array, so A2 to G31, and then I return the Bulls, or the home side's 2-point defensive rating. So essentially it's the attacking rating for the away team multiplied by the defensive rating of the home team. Then I've got to multiply by the average 2 points made per match, and that's in B33 in NBA team stats, 27.6, before I multiply by the away side advantage, which is technically a disadvantage of 0.988. So the formula for finding the away side or home side's expected 2 points, 3 points, and free throws is their attacking rating in that metric, multiplied by their opposition's defensive rating in that metric, multiplied by the average number league-wide, and then multiplied by the away or home advantage, depending on if they're the away or home team. I can copy and paste that formula into cell B6 and change the home side or the away side to the home side. So F1 goes to G1, G1 goes to F1, and the advantage goes from B2 to B3. So when I press enter, the Atlanta Hawks are expected to score 10 more 2-pointers than the Chicago Bulls in this match. I can do the same thing in the away expected 3 points formula in cell B8. This time though, I've got to change the column index numbers so that instead of looking up the attack and defensive 2-point ratings, I'm looking up the attack and defensive 3-point ratings. So it's in the same array, but I'm looking up the ratings in columns 4 and 5, and then multiplying by the average 3-pointers made by a team each game, and then of course multiplying for the away side by the away advantage in cell B2 of this worksheet. So when I press enter, the Hawks are expected to score 12.2 3-pointers in this match against the Bulls. Paste that into the cell below again, change F1 to G1 and G1 to F1, so we're looking up the home side's attacking rating and multiplying by the away side's defensive rating, and then change the away advantage to the home advantage. So here the Bulls have quite a significant 3-point advantage, and I'll just do the same thing for the expected free throws. Of course, the column numbers will change from 4 to 5 to 6 and 7. Column 6 and 7 in A2 to G31 are the free throw attack and defense ratings. And then I'm multiplying by the average number of free throws made per match. That's the scale. And then multiplying by the away advantage for the away team. So again, copy and paste that into the cell below. Change F1 to G1 and G1 to F1. And then change the advantage from away to home. If this is moving too fast, lads, just pause the video and then write down this formula for yourself. Now, the away expected points is a really easy calculation. It's equal to the expected 2-pointers times 2 plus the expected 3-pointers made times 3 plus the expected free throws made times 1, or by itself. And so I can do the exact same thing for the home expected points. B6 times 2 plus B9 times 3 plus B12. And then we can see the Chicago Bulls are expected to win this match by a slight amount. Now, while they're expected to win, the Bulls, we can't just say they win every single time. There's an element of luck in every single basketball game, so we've got to simulate these results based on the expected values for the 3 methods of scoring. So to start, we can simulate the Atlanta Hawks regular time score by using the binomial inverse function, where there's 10,000 trials. The probability S is the expected 2 points divided by 10,000, the number of trials, and then the alpha argument is a rand function, open bracket, close bracket, and then multiply that by 2 to find the expected, or simulated points rather, coming from the expected number of 2-pointers made. So I can do the same thing for the expected number of 3-pointers. I can simulate that using the binomial inverse function and then multiply it by 3 to get the number of points coming from 3-pointers in this simulated match. And then I'll do the exact same thing for the away free throws. So in this game, the Atlanta Hawks scored 112 points, but when I simulate it, it changes every single time because the number of 2-pointers, 3-pointers, and free throws are simulated along the binomial distribution in this match. And then for the Bulls, I just need to copy and paste the formula into cell G2 and then change the values from the away side's expected values to the home side's. So B6 divided by 10,000, B9 divided by 10,000, and B12 divided by 10,000. And when I press enter on that, I get a simulated score of 109 to 108. So this game doesn't need to go to overtime. But, you know, if it was 108 to 108, the game doesn't just end there. I've got to come up with a formula to simulate 5 more minutes of playing time if the regular time score is still the same. And to do that, I'll use an if function where if F2 is equal to G2, put a $ in front of the columns F and G, then return a binomial inverse function where there's 10,000 trials and the probability S will be open bracket 5 divided by 48 close bracket times B5 divided by 10,000 comma, and then a rand function for the alpha and close the bracket there, multiply by 2, these are the simulated number of points deriving from 2-pointers in this simulated overtime 1 period. Now, add the simulated number of points coming from 3-pointers, and of course for the probability S, multiply it by 5 divided by 48, which returns 5 minutes of simulated points. Now add the binomial inverse function for the free throws made as well, divided by 10,000, comma, rand for the alpha argument, close the bracket there, and then I'm going to add F2. So whatever score they get in that 5 minutes is of course added to the score they got in regular time. And you know, if F2 is not equal to G2, then just leave the score in F2. So I can drag that formula across and down to cell G5, and then the scores in cells F6, or rather F5 and G6, are the final scores for that game. So the scores stay the same if they're not equal in F2 and G2, but if they are equal, then 5 minutes of overtime is played. If they're still equal, then another period of overtime is played. So now I can simulate this single game result 2,500 times to get an idea of the distribution and to find the probabilities for the 3 betting markets I have in the dashboard worksheet. So put the 2 teams in cells J1, K1. In I2, write the text trials, and below it, I'm going to spill 1 through to 2,500, and that just represents trial 1, trial 2, all the way down to trial 2,500. Now in cell J2, I'm just going to go equal F5 in K2 equals G5, and that's the simulated score for this match. Now I'm going to simulate this simulated score 2,500 times using a data table. So select this range, go into data, select what if analysis, and in your data table for the selected range, put a column input cell outside of the selected data set. And then once you press OK, all the simulations will load, and we can analyze them now. Of course, going one by one, the Hawks just lose this game. They win the next one, they win the next one, they win the next one, and then they lose this game 111 to 150. They lose the next game 107 to 123. So you can see all these results are simulated according to the expected values in column B that we calculated. And whenever I press refresh all, or press backspace, or alter another cell, the simulations will actually update. Now that we've finished that worksheet, I can go back into the dashboard, and in cell L2, I can pull in the expected points for the away team in this matchup, and that's just equal to the cell in simulations with the away team expected points, that's B14. And then in L5, it's just equal to L15 in the simulations worksheet, the cell below that. This figure will never change. It's just the expected value, or the average number of points you'd expect the Hawks and Bulls to score in each simulated game. Now to pull in the probability of the Hawks winning the match, I'm going to count the amount of times they beat the Bulls in each of the 2,500 simulations in the simulations worksheet. So to do that, I've used the sum product function, open the bracket, put a double negative, then open the bracket again. We're counting the amount of times that in cells J3 to J2502, the scores for the Atlanta Hawks, are greater than the corresponding cells in K3 to K2502, the score the Bulls got. Close the bracket twice. That's how many times the Hawks beat the Bulls. Now divide by the number of trials, 2,500, to get a probability. And in this lot of 2,500 simulations, the Hawks won 46.76% of the time. Now, because they're simulations, they naturally change. So each time you press enter or update a cell, there'll be some variation. So for the Bulls, it's just less than, the sum of which should be exactly equal to 1, unless there's any games that go past overtime 3, very unlikely. But if I update the 2,500 simulations again, there's a slight change. And with 2,500 simulations, this may change from about 0.5% to a percentage point each time. But the more trials you do, the less this variation or variance becomes. Now, if I change the matchup to the Blazers at the Rockets, then not only does the expected points update, but also the win probabilities for each team. So I can now fill out the 3 markets and find the true odds for all of them. For the Blazers, they've got a win percentage of 22.28%. I'm now going to return either the American or decimal odds for that probability according to what you want. So in cells Q2 to R3, merge and center those cells and put the text odds. Do that for the same thing in S2 to T3, but instead there, I'm going to go into the data tab, and using data validation, I'll make a list where you can choose from American or decimal odds to display in cells C10 and C11 next to the win probabilities for the Blazers and Rockets. I'll select American odds first, and to bring in the American odds for the Blazers and Rockets winning this match, I'll need to use the following formula. So in cell C10, put equals, open bracket. Our test is whether S2, absolute reference this, is equal to American in speech marks. If that's true, then we'll return the formula for the odds. Now this is another if function. We've got to determine if B10, the win probability, is less than or equal to 0.5. If it is, then in speech marks, plus space, close the speech marks, and use the round function where the number is equal to, after 2 brackets, 1 divided by B10, close the bracket, minus 1, close the bracket, multiplied by 100. Now, comma, the number of digits you're rounding to is 0, and then close the bracket. If that's false, or the number in B10 is greater than 0.5, then return a negative sign, space, in speech marks, and minus round, open bracket, negative 100 divided by 2 opening brackets, 1 divided by B10, close the bracket, minus 1, close the bracket, rounding to 0 digits, close that bracket twice. If all of that is false, then it'll be decimal odds, which is equal to 1 divided by the probability in B10. So the Blazers are at plus 352 in C10, and the Rockets, as the favorites, are minus 368. So now for the spread, we've got to choose a threshold, and this is applied to the home team. So if it's a positive value, we'll give the home team an advantage. Right now, we'll handicap the home team 16.5 points. So the threshold in B14 is negative 16.5. So that'll make the probability of the Blazers and Rockets covering the spread at around 50% each. And so to calculate that in cell B16 for the Blazers, considering this advantage, use the sum product function where after 2 negatives, open bracket, the simulations in J3 to J2502 minus the threshold we set in the dashboard worksheet in cell B14. So make sure you absolute reference that by putting a $ in front of both the column and row. Has to be greater than the simulations in the next column over, or the simulations for the Rockets. So that's equal to simulations K3 to K2502. 2 closing brackets, divide by 2500, the number of trials, and the Blazers, using the 16.5 point disadvantage for the Rockets, have a 51.12% chance of covering the line. Now for the Rockets, I'm just going to copy and paste the formula in B16 into B17 and change a couple of things. So the formula will change to the simulations in J3 to J2502 have to be less than the simulations in K3 to K2502 plus the threshold in B14. So when I press equal, or enter rather, then the cells in B16 and B17 update, and the sum has to be equal to 1. Now for the odds, I can just copy and paste cells C10 to C11 into C16 and C17, and when I update the probabilities, because they're so close together, the variance will be about, again, 1% or so. Now for the under over, I can also set a threshold in cell B20 at 231.5 points. Now, copying the formula in cell B16, I can paste that into B22 and get rid of the threshold of B14. The formula is going to be J3 to J2502 plus K3 to K2502 has to be less than B20 for the under. So the points of the Blazers and Rockets in each game has to be under 231.5 points. And this happens 75% of the time. When I copy and paste that formula into B23, the only thing I have to change is instead of it being under, it has to be over the threshold. So when I press enter on that, I can get the over probability, and again, the sum of which has to be equal to exactly 1. Because it's 231.5, there can't be any instances where it'll be exactly equal to 231.5. It's a decimal, so if I change it to 216.5, because that's virtually the sum of the expected points above, the probabilities converge to about 50% each. So if I change the teams now, for any matchup, the money line, spread, and under over will update. For the Clippers and Kings, the Kings are the slight favorite when the spread is changed to negative 16.5 points. It's in the Clippers' favor. However, when I change it to minus 3.5, then it updates accordingly. Now for the Pacers versus another team, let's select the Bucks. The Bucks become the favorite here. They've got a 60% chance of winning, and again, all the markets update. So lads, if you want to change the odds to decimal, just go ahead and select decimal in the drop-down list in cell S2, and then all the odds change to decimal formatting. So I'll reduce this to 2 decimal places, as well as copying the odds into cells C22 to 23. Now, if you want to update the Power Query, go into the Data tab and select the Refresh All icon. This will update the model and bring in the newest stats from Basketball Reference instead of you having to copy and paste the stats in every day. Thanks for watching, lads. If you want to download this model, then make sure you click the first link in the description below.